wondered whether outside our universe there exist countless other universes? Or perhaps our universe is just one tiny universe among countless universes? When mentioning the multiverse, we often think of the concept in science fiction movies, but it actually has nothing to do with modern physics. If you move in the universe in a fixed direction long enough, you will return to your starting point. Astrophysicists all agree that the universe is currently expanding, which means travel time will increasingly grow. So what is causing our universe to expand? People try to answer this question with the theory that our universe is just one of many bubbles created from the Big Bang. As Fraser Kane from Universe Today explains, one of the most fascinating and shocking ideas is that the universe we live in is actually just a tiny universe within a vast multiverse. Each universe is like a soap bubble in cosmic space, and each tiny universe is born from its own Big Bang. It's like a giant sponge, with countless tiny universes continuously emerging. This theory also suggests that in each tiny universe, completely different laws of matter exist. As known, matter in our universe is governed by many physical laws, such as the magnitude of gravity, the strength of atomic bonds. These numbers would differ in each universe, and they are thought to change randomly like rolling dice. Life hardly exists in most cosmic bubbles. However, if you roll the dice countless times, there will be some universe with the right numbers to form life. It sounds far-fetched, but in reality, there are many methods of measuring the universe that astronomers are using to test this theory. If these cosmic bubbles expand far enough, they will begin to interact with each other. And based on observations, there is some evidence showing that our universe is interacting with other universes. Looking at the cosmic microwave background, CMB, the residual thermal radiation from scientists have found temperature fluctuations, also known as thermal anisotropies. As the universe expands, the difference in matter density between regions will increase. Most temperature fluctuations can be explained by the current cosmological model. But there's one region that cannot be explained by these theories: axis of evil. There are many theories explaining the axis of evil, one of which suggests this is the point where our universe comes into contact with another tiny universe. This region is billions of light years away from us, so any impact on physical laws caused by the collision between two universes would certainly not affect us. We need to continue observing to verify and better understand this issue. According to current understanding, the universe has been expanding since the Big Bang 13.8 billion years ago, and this expansion is accelerating with increasing acceleration. The expansion rate is known as the Hubble constant, and astronomers have spent years trying to measure this rate accurately. But recently, with what is considered the most accurate measurement to date, experts found that the universe is expanding 8% faster than predicted. This number doesn't match measurements of the residual radiation from the Big Bang era. This means that, if the measurement is confirmed by further research, just mathematics, assuming we live in a multiverse composed of countless parallel universes, has long been considered a scientific possibility, though still hotly debated. The immediate problem is to find ways to test this hypothesis, including scanning the sky for signs of collisions with other universes. It's important to remember that the multiverse concept isn't, but rather a consequence of current understanding in theoretical physics. This distinction is crucial. We can't just wave our hands and say let there be a multiverse. Instead, the idea that this universe might be just one among countless others has originated from current theories like quantum mechanics and string theory. You might have heard of physicist Schrödinger's thought experiment about the cat. The terrifying animal is locked in a sealed box. The act of opening the box allows us to observe one of the possible future outcomes of the cat. including the case where it is both aligned. This sounds absurd, simply because human intuition is not accustomed to such an idea. However, it is entirely possible, based on the principles of quantum mechanics. The reason this can happen is because the possibility spaces in quantum mechanics are quite large. Mathematically, a quantum mechanical state is the sum, or superposition, of all possible states. In the case of Schrödinger's cat, the cat is the superposition of two states, alive and dead. Let's explain this in a more practical and understandable way. Think of all these possibilities as recording devices, where we can only observe the cat's objective state. However, we can also choose to accept all these possibilities and that they exist in different universes of a multiverse. The cat may be alive in this universe but dead in another, but we can only see one state here. String theory is one of the most promising paths, capable of unifying quantum mechanics and gravity. This is an extremely difficult problem because it is very hard to describe gravity on small scales, such as the scale of atomic and subatomic particles, which belong to the domain of quantum mechanics. But string theory, which posits that all elementary particles are made of one-dimensional strings, can simultaneously describe all known forces in nature, including gravity, electromagnetic force, and nuclear forces. However, for string theory to work mathematically, it requires at least 10 physical dimensions, since we can only observe 4 dimensions, including height, width, depth as 3 spatial dimensions and time. Therefore, the additional dimensions in string theory must be hidden somehow if they truly exist. To use string theory to explain the physical phenomena we see, these extra dimensions need to be compactified by curling them into sizes so small they are unobservable. For each point in the 4 main dimensions, there may exist 6 other uniform directions. One problem, or as some say, a feature of string theory is that there are many ways to compactify, and 10 to the power of 500 is a commonly cited number. Each compactification method will create a universe with different physical principles, such as different masses of electrons and different gravitational constants. However, there are also strong objections to the methodology of compactification, so this issue remains unresolved. Based on this, the obvious question to ask is, which of the above possibilities are we living in? String theory itself does not provide a mechanism to predict this, making it useless because we cannot test it. But fortunately, an idea in the field of early universe cosmology has turned this technical flaw into a special feature. In the early stage of the universe before the Big Bang, the universe underwent a period of rapid expansion called inflation. Inflation was initially proposed to explain why the observable universe today is almost uniform in temperature. However, this theory also predicts a range of temperature fluctuations around thermal equilibrium. This has been confirmed by several spacecraft such as the Cosmic Background Explorer satellite, the Wilkinson Microwave Anisotropy Probe, and the Planck Space Telescope. Although there is still heated debate over the specific details of this hypothesis, physicists widely accept the concept of inflation. However, an inevitable consequence of this hypothesis is that other regions of the universe must still be accelerating in expansion. However, due to quantum fluctuations of spacetime, some parts of the universe never actually reach the final state of inflation. This means the universe, at least according to our current understanding, will expand forever. Some parts of the universe may therefore become other universes that themselves can become yet other universes. And so on. This mechanism will create countless, innumerable universes. By combining this scenario with string theory, it is possible that each universe will have a different compactification method of the extra dimensions, and thus will also have different physical principles. The universes predicted by string theory and by the inflation hypothesis will exist in the same physical space. Unlike many quantum mechanical universes that exist in a mathematical space, they can overlap or collide with each other. Indeed, they must certainly collide with each other, leaving traces in the cosmic sky that we might be able to search for. The specific details of these traces depend closely on the models of the universe. From hot or cold spots in the cosmic microwave background radiation, to anomalous voids in the arrangement of galaxies. However, since collisions with other universes must occur in a certain direction, any trace would likely break homogeneity. This observable universe of ours is a common expected possibility. These traces are being actively sought by scientists. Some are searching for them directly through boundaries in the cosmic microwave background radiation, which is the residual glow after the Big Bang. However, no such traces have been discovered yet. Others are searching for indirect support such as gravitational waves, which are ripples created in space-time. When extremely massive celestial bodies, such ripples could directly prove the existence of the inflationary period, thereby supporting the multiverse hypothesis. Will we be able to prove their existence in the future? This is hard to predict. However, with such significant implications, the search for them is entirely worth the effort. Thank you for watching the video.